So we are out in the field today learning about the Augmenta Sensor. Another day in the life of a CEO of just exploring new technologies and new opportunities and seeing what's out there and how it works and where it could potentially fit in a grower's business.
Is how this thing works. It's ISO bus into the John Deere monitor. So that means it can plug into anything. ISO bus means it basically it adheres to the generic format of all of the electronics. So we talked a lot today about seeding prescriptions. I'm telling you, this is the optimal area for the kinds of prescriptions that we're creating. If you look off in the distance, you can see the tops of the hill. Obviously, the water is going to shed off of the top of that hill. It's going to land in the valley. It looks like the sweet corn patch lands in the valley. If that was a continuous field, we would have the ability to up populations of corn where it's sitting like this, and lower populations of corn where it's sitting like this. And Matt on the way down here talked about, well, how do you decide what populations? And that's where a relationship with a reliable seed dealer really is valuable, because that dealer can help you pick variety, and then it can help you target a population, an average population for a field. And then we can simply increase it by a percentage in the areas where we know it'll pay, and decrease it in other areas of the field where it won't pay. And we've got lots and lots of research trials where we're running over those different areas and helping to fine-tune those populations by farmer, by variety, by field.
Cool.
So I'm Matt Garber. I'm head of customer success for Augmenta in North America. We're here in southern Ohio looking at a sprayer outfitted with the Augmenta system.
Let me come in and shut the door. Go for it.
So I fired up the iPad and it connects to the device via Wi-Fi. It's a local Wi-Fi signal sent out from the device just to connect to this iPad. That's all it's for. So we'll hit this button here with the Augmenta emblem, and we're going to choose field monitoring, which is simply keeping track of the NDVI index in a field and taking a red, green, blue 4K resolution snapshot about every 100 yards. So we're going to select the line-by-line spacing, which is 90 feet. This rounded down to 89.9, but we're there. Crop type, we're just going to call it grass because we're just going to drive down the driveway. Check mark, check mark. There we go. We're ready to go. It's scanning out in front. It sees an unrecognized area, which is probably the door on the shop. And on the edges where nothing's showing, it realizes that's like bare ground. That's the gravel. So if Luke's out of the way, we can drive down the driveway and watch this thing change. So we're going to go ahead and drive. Look at that, it has a cell phone holder. That's cool.
That is
That's
nice.
exactly what that is.
Does it charge too?
I don't know. See, you still see
your
it?
starter. Yep.
Yeah, need a horn. But anyway.
Yeah, I see Luke. He's
Okay.
fine. We're not gonna put him under the tracks. All right. So this thing.
Go ahead.
This thing is actually scanning the NDVI values there.
As we turn and hit this driveway, we should start to see bars come up on this thing.
Oh yeah, we just changed.
Yep, see we're losing the door. There,
Okay.
see the green coming up?
Yep.
It's starting to scan the left edge.
Okay.
But as we go forward, we should see a difference. When it has gray bars, that means unrecognized value.
Okay, so that's probably the in front of us, the path that's in front of us.
Yeah.
And then it's measuring.
And then see the real low bars? That's the dried down corn probably.
Okay.
And then admittedly the field falls off there, so its field of view is out there a ways. But then on the right, it's picking up all this grass that's next to us. Oh, look at that. These are the tracks.
Yep.
And in the middle is that little skiff of grass.
Yep. I'll be darned.
It changes a little bit in what it's perceiving.
Right.
So we won't go a long ways. We'll just turn around here and drive up by the tanks. That's pretty cool.
So this machine is designed to scan, evaluate the quality or the
the
health,
yeah.
health of the turf or health of the crop.
Yep, and biomass.
Yep.
Yep.
And then decide nitrogen, in this case, nitrogen rates.
Yes.
We're getting ready to turn into turf, so I expect it to really do something different. Yeah, now you look, make sure I got the monitor, but you can clearly see that as it saw pure biomass, it certainly changed.
There's the road coming up with the gravel drive coming back up into view.
Yeah. So Matt, one of the things we talked about was when it sees something anomalous, it takes a picture.
Yes.
Would it have just taken a picture as we were changing something there?
We'll have to look at the data, but yes, it should have taken it on at least 100-yard cadence, and then if the video stream deviated from what it had seen previously, it would have. I don't know if it went quite far enough to start doing stats there on that, but yes, that's what it does in the field. Absolutely.
Is it difficult to hook the system up to the John Deere sprayer to change? Have it actually do control?
To make it control?
Yep.
The physical installation, or you mean just triggering it right now?
Getting all the electronics to talk to each other.
It's not. It requires getting into this panel back here and plugging into the side of the box, and I don't know the proper term for that box there, but there's an open port.
ISO-bot, yeah.
You just plug into that and go in here and just go to your COM port settings and make sure we have COM2. It has an in-sensing on it, and that's what lets it talk to each other with the common language. So I'm going to go ahead and stop the session. So we're going to hit stop. Now, if someone's doing this in the field, it's very nice to go ahead and put a little note in here, like with the field name. I'm just going to call it test. And hitting with the Gen 4 display in the sprayer. So we'll put in a test dose of 35. We'll go ahead and hit test. Now look down here on the display. Target rate wet, 35 gallons an acre. And we're active on the D2 message and active on communication status. So it is doing what we want it to do.
Okay. And you actually set it up. You guys must use the same protocol on the display as the Yara sensor. So you can basically set it like it's a Yara sensor, even though it's the Augmenta sensor.
I think they use a similar language, yes.
Yep. Okay, makes sense.
So
good way to show. So obviously we're not applying today. We're just basically between the two systems. But as you make changes on the iPad. I'm going to zoom in here so people can see that. As we look, you changed it to 3 gallons per acre. We come over here, and there's the 3 gallons per acre. So cool.
Yep, very cool. And then obviously, if we were running across the field, this thing would be live feeding that right into it and changing the rate as we go.
Right.
Yeah, it's pretty cool. Farmers immediately grasp what this does and why it's important. They will carry on a conversation about this every time.
Yep. And it's being able to live sense in the field and changing it on the go is what makes sense.
Yes. Yeah, based on the environmental conditions at that point. And then, of course, you can also add in, as we've talked about, underlying layers. This is a tool for agronomists. This is not a black box. This is a tool. So using history and soil types and yield maps and other environmental factors that the agronomist is privy to, has historical knowledge of, you can add that as an underlying layer and divide the field into zones. And then this device can have a unique curve of application in every single zone. Has been designated up to 5 zone classes per field.
So what you basically would say is you can designate like an average target rate within each zone, and then the system will go up and down from that accordingly.
Exactly. Yep.
Okay.
Very cool. Okay. So this is the Omnibox, and this cable here runs to the module inside the sprayer and sends direction to it. Then this cable here goes to the device on the roof. So the tablet, all the tablet is used for is communication. That's all. The device on the roof has the CPU in it and does the processing and sends the command to the module in the sprayer and then on to the controller to change the rate and out the boom.
Okay. So that right there is like directing traffic is basically what it's doing.
It is.
The brains are up on the roof.
Absolutely.
Okay.
And then if you were to have an ISO installation, this box can handle ISO communications as well.
Okay.
So here
out to the sprayer.
Right.
Yep.
Well, to the controller.
Right.
Yeah. Yep.
Yep.
So this, in this situation, you know, it's not as playing as big a role as in the ISO situation.
Okay.
Yep.
This would be the area that he was scanning, the middle of the path where it was picking up the corn on the outside and the turf on the inside. And then as he turns this corner right here, that's where it changed. And because it was scanning over there where the turf is, 100%, it was 100% picking up the vegetative values. Obviously the driveway has no vegetative values. It seems like the installation is relatively easy, straightforward.
I was just talking about using that thing. I think it would be cool to use it as a scouting tool.
Well, did you see as you went down the path how it could differentiate the center of the path from the...
Yeah.
And then it was picking up the corn on one side and the turf on the other. And then as you made that corner, you could see where it went continuous to all. So how many channels is it tracking across it?
20.
20 channels. You could see all 20 channels convert to where it's now picking up vegetation.
Yeah, I thought it was pretty. I can see that as a really cool utility for like scouting, potentially.
I think that the AI based, if you could figure out how to get it to diagnose things from those pictures in real time and alert you somehow, Matt, that's what would be interesting. How do you got the mount up there, Matt?
What's that?
How do you got the mount up there? What'd you have to do to mount that aluminum mount up there?
Oh, yeah, go ahead and look. We used the back two cab holes.
So the reason it's mounted out to this the
It was clear the flow mostly. If there's a little bit of the nose in the view, it takes that out.
Okay.
It does.
Just curious.
That. Some of our snapshots will have the tractor.
And the sensor on top, that white
That
globe is what's
for
sensing.
sun directionality.
Okay.
And then that clear lens on top, that is to look for cloudiness, brightness of the day.
Okay. So the opaque one does direction of the sun, or basically angle of the sun, and then the black one does intensity.
Looking up, yeah, that and cloudiness.
Okay.
Because your direction has to pass, and sun
Sure.
orientation matters.
For sure. That was one of my concerns with it not being an active sensor, was you're using the sun as your source, so you got to be able to account for variations from your source that are environmentally related.
Yeah.